sweet like a buttercup. You're a Barbie doll. Show them all what I'm made of. Strut down the hall. Won't stop till I get enough.
Okay, so you know that feeling, right? Like when you were a kid and you're like convinced there was a monster under the bed. Well, imagine that feeling, but the monster is a giant asteroid, and the under the bed is like Earth in 2032. We're going to do a deep dive on this today based on this YouTube video from Hank's channel. It's called About That Giant Asteroid. And, it's not about fear-mongering everything. We just want to like sort of explore what we know about this potential close encounter. So how worried should you be about an asteroid potentially hitting Earth in 2032? Let's unpack this.
Yeah, definitely worth taking a closer look. I think the first thing to understand is that this asteroid is massive. The potential impact force is something like 1,000 Hiroshima bombs.
1,000 Hiroshima bombs. Okay, that sounds pretty terrifying.
That is a huge amount of energy. But here's the thing. Humans have already built bombs that powerful. We've even detonated them on Earth. The crucial difference here is that the Hiroshima and Nagasaki bombs were targeted at cities, while this asteroid, if it were to hit, would likely impact a less populated area.
That makes sense, but like, if it did hit Earth, where are we talking?
Current projections suggest an equatorial impact zone, stretching from South America to India.
So maybe hold off on booking that trip to the Amazon for now. But I guess that still leaves most of the planet untouched, right?
Exactly. And remember, most of Earth's surface is uninhabited.
Okay, that is kind of reassuring. But it makes you wonder, like, just 50 years ago, we wouldn't even have known about this asteroid. Our ability to, like, track these objects in space has come such a long way. It makes you think maybe ignorance was bliss.
Perhaps, but knowing about potential threats is actually crucial. It gives us the chance to prepare and potentially even prevent them. This awareness might feel a little unsettling, but it's far better than being caught completely off guard.
I guess you're right. But so is this thing going to cause a global extinction event like in the movies?
Not this time. This particular asteroid, while significant, isn't large enough to wipe out all life on Earth. But it could still cause considerable damage and loss of life. It's definitely something we'd want to avoid, for sure.
So not the apocalypse, but definitely not a good day at the beach either. But here's the interesting part. Unlike in the past, we actually have technology that could potentially deflect an asteroid like this.
That's a key point. NASA's DART mission actually demonstrated that we can alter an asteroid's trajectory in space. They successfully nudged a small asteroid off course, marking a significant step forward in planetary defense.
Wait, we can actually do that. That's not just science fiction anymore. That's amazing.
It's a groundbreaking achievement, and it raises a crucial question. If we can deflect a small asteroid, could we apply the same principles to a larger one? And what other technologies could we develop for planetary defense?
Those are some big questions. But before we get ahead of ourselves, I think it's important to address how the media sometimes portrays these scenarios.
You're right. The media often focuses on worst-case scenarios, multiplying a small chance of impact with a minuscule probability of hitting a densely populated area. Suddenly, it seems like the end of the world.
It can definitely be scary when things are presented that way, but we need to keep a clear head and focus on realistic risks, not just dramatic headlines.
Exactly, and it's essential to understand the science and technology involved so we can make informed judgments about the actual level of risk.
Okay, so let's break this down for our listener. There's an asteroid that might come close to Earth in 2032. It's not an extinction-level event, but it's something to monitor closely. The good news is we're in a much better position than ever before to detect and potentially deal with these kinds of threats. We've gone from being passive observers to potential actors in space.
That's a great summary. What's fascinating is how much our understanding of space and our ability to act within it has changed in just a few decades. It makes you wonder what the next 50 years will bring in terms of space exploration and planetary defense.
That's a great point, and this entire situation really highlights how far we've come in a relatively short time. But before we dive into those potential advancements, let's go back to this specific asteroid for a moment.
Sounds good. What specifically are you thinking about?
Well, we've talked about the size and potential impact zone, but we haven't really discussed what makes an asteroid a threat in the first place. What exactly is this thing made of, and how does that factor into the potential damage?
That's a great question. It's not just about size, but also composition. Some asteroids are primarily rock, while others are metallic. A metallic asteroid could be denser and potentially cause even more damage upon impact.
So figuring out what this asteroid is made of is a big part of understanding the risk it poses?
Absolutely. Knowing its composition allows scientists to model its trajectory more accurately and assess the potential consequences of an impact. And it also plays a role in determining the best way to potentially deflect it.
Okay, so we've established that this asteroid is big, it could potentially hit in a less populated area, and we need to figure out what it's made of to understand the risk fully.
That's a good summary, and it's essential to remember that this is just one asteroid. There are countless others out there, and we're constantly discovering new ones.
So this is just the tip of the iceberg when it comes to planetary defense.
It is. It's a field that's constantly evolving as we learn more about our cosmic neighborhood and develop new technologies.
This is all incredibly fascinating. But it also makes you think about the bigger picture, doesn't it? Like, what are the chances of an asteroid actually hitting Earth? And how does this specific asteroid compare to other potential threats out there?
Those are great questions that we'll delve into in part 2 of our deep dive. We'll explore the history of asteroid impacts, the statistical probability of such events, and how scientists assess the risk posed by different asteroids.
Sounds like we have a lot more to uncover, and we'd love for you to join us on that journey as we continue to explore the world of asteroids and what they mean for our planet.
See you in part 2.
So last time we were talking about this one specific asteroid that might swing by Earth in 2032. And it got me thinking, like, how often does this kind of thing actually happen? Is it like a once-in-a-blue-moon situation? Or are we dodging space rocks more often than we realize?
That's a great question, and it really gets to the heart of how we understand risk in the context of asteroids. I think maybe it would help to take a step back and look at the history of asteroid impacts on Earth.
Okay, history lesson time. So how far back are we talking?
Well, the Earth has been bombarded by asteroids and comets throughout its 4.5 billion year history, but we only have detailed records of impacts going back a few thousand years.
So like dinosaur times.
Exactly. The most famous example is the Chicxulub impact. You know, the asteroid that wiped out the dinosaurs about 66 million years ago. But even in more recent history, we've had significant impacts.
Right. I remember learning about the Tunguska event in Siberia in 1908.
That's a classic example. An asteroid or comet about 120 feet across exploded in the atmosphere over Siberia, flattening trees over an area of 800 square miles.
That's huge. And we've had more recent events too, right?
Yeah, there was the Chelyabinsk meteor in 2013, a smaller asteroid that exploded over Russia.
Oh yeah, I remember seeing those videos online. It was crazy. All those windows shattering from the shockwave.
Yeah, that event really highlighted how even relatively small asteroids can cause damage and disruption.
Okay, so it's clear that asteroids have hit Earth in the past. And it's not a question of if, but when it will happen again. But how do scientists actually figure out the odds of an impact?
Well, that's where the field of asteroid impact prediction comes in. Scientists use powerful telescopes to scan the skies, constantly searching for new asteroids and tracking their orbits.
So it's kind of like a cosmic neighborhood watch.
Yeah, you could say that. They calculate the trajectories of these asteroids, factoring in gravitational forces from planets and other celestial bodies.
And then they can tell us if there's a chance an asteroid might come close to Earth.
Exactly. They use complex algorithms to calculate the probability of an asteroid crossing Earth's orbit.
Okay, so they're basically playing cosmic billiards, trying to figure out if a ball is going to hit the pocket.
That's a good analogy. And just like in billiards where a slight change in angle can make a big difference, small uncertainties in an asteroid's trajectory can have significant implications for impact predictions.
So they're dealing with a lot of variables and trying to make predictions about something millions of miles away.
Yes, it's a challenging task, but it's getting easier as our technology improves. We're getting better at detecting and tracking asteroids, and our models are becoming more accurate.
So back to the asteroid we've been discussing, the one that might come close in 2032. Where does it fall on the risk scale?
Well, it's currently classified as a potentially hazardous asteroid, or PHA.
Potentially hazardous. That sounds ominous.
It just means that it's large enough and its orbit comes close enough to Earth so that it warrants careful monitoring.
Okay, so it's on the watch list, but it doesn't necessarily mean we're all doomed.
Exactly. Remember we were talking about probabilities. In this case, the probability of an impact in 2032 is currently estimated at around 2%.
2%. Well, it's not zero, but it doesn't sound like we need to panic just yet.
That's the right way to think about it. We need to stay informed, but we shouldn't let fear dictate our actions.
But even if the odds are low, wouldn't it be better to be safe than sorry? Like, what are we doing to prepare for the possibility of an impact?
That's a great question that leads us to the fascinating world of planetary defense. It's a relatively new field, but it's rapidly advancing.
Planetary defense, it sounds like something out of a sci-fi movie.
It does, isn't it? But the reality is that we're now at a point where we're not just passively observing these potential threats, we're actively exploring ways to protect ourselves.
So what are we talking about here? Giant laser beams, nuclear missiles.
Well, those are some of the more dramatic ideas that have been explored. But the most promising and realistic approaches involve deflection techniques.
Deflection, so like nudging the asteroid off course so it misses Earth.
Exactly. Remember the DART mission we talked about earlier? That was a test of a kinetic impactor, basically a spacecraft that crashes into an asteroid to change its trajectory.
So we're basically playing cosmic billiards, but with much higher stakes.
You could say that. And there are other deflection techniques being explored as well. One is a gravity tractor.
A gravity tractor? What is that, some kind of spaceship with a giant magnet?
Not quite. It's a spacecraft that would use its own gravitational pull to slowly tug an asteroid off course over time.
So it's like using a tiny tugboat to move a giant ship.
Precisely, it would be a slow and delicate process, but it could be effective for deflecting smaller asteroids.
This is incredible. We're talking about moving mountains, or rather moving asteroids in space. But let's be realistic. Are these technologies really feasible?
It's still early days, but the progress we've made in recent years is encouraging. And the DART mission proved that we can actually change an asteroid's trajectory.
Okay, so we're not just talking about theoretical concepts anymore. We've actually taken concrete steps towards developing planetary defense capabilities. That's pretty amazing when you think about it.
It is, and it highlights the importance of investing in scientific research and technological development.
So we're not just sitting ducks waiting for an asteroid to hit us. We're actively working on ways to protect ourselves. But it can't just be about technology, right? I imagine there are a lot of international collaborations involved.
You're absolutely right. Planetary defense is a global issue that requires cooperation between nations. Sharing data resources and expertise is crucial.
Yeah, it really underscores the idea that we're all in this together.
Exactly. And it's not just about governments and space agencies. The public also plays a vital role.
What do you mean, what can we do as individuals to be part of planetary defense?
For starters, stay informed about these issues. There are countless resources available online, from NASA's website to educational YouTube channels.
Speaking of YouTube, that's where we went on the video that inspired this deep dive.
Right. Engage with those resources, ask questions, and spread the word. The more awareness we raise, the more support we can build for planetary defense initiatives.
So it's not just about scientists and engineers. We can all play a part in protecting our planet.
Exactly. And remember, knowledge is power. The more we understand about asteroids and the risks they pose, the better equipped we'll be to make informed decisions and support efforts to mitigate those risks.
Okay, so we've covered a lot of ground here. We've talked about the history of asteroid impacts, the probability of future events, and the emerging field of planetary defense. But there's another layer to this whole conversation that I think we need to address.
I agree. It's not just about the science and technology, but also about the human element.
Exactly. We've been talking about asteroids in a somewhat detached, analytical way, but the reality is that the possibility of an impact raises some profound existential questions.
Absolutely. It forces us to confront our own mortality and the fragility of life on Earth.
It's a cosmic wake-up call in a way.
It is, and it makes you wonder, how would we react as individuals, as societies, as a species, if we knew for certain that a large asteroid was heading our way?
That's a deep question, and it's not one with easy answers. But I think it's a conversation worth having.
I agree. It challenges us to think about what truly matters in life and how we want to spend our time, knowing that it might be limited.
It's a heavy topic, but it's also incredibly thought-provoking.
It is, and it's something that we'll explore further in part 3 of our deep dive.
So as we head into the final part of our exploration, I want to leave you with this question. If you knew an asteroid was coming, how would you live your life differently? What would you prioritize? What legacy would you want to leave behind?
Those are some powerful questions to ponder.
They are, and we'll be back soon to delve into those reflections and explore the deeper meaning of this cosmic dance we call life.
See you in part 3.
So welcome back to our deep dive into the world of asteroids. And in the last 2 parts, we've covered a lot of ground, from the science of asteroid detection and deflection to the potential impact on Earth and the, emerging field of planetary defense.
Yeah.
But we ended on a pretty heavy note, asking you, how you would live your life if you knew an asteroid was on a collision course with Earth.
It's a question that really pushes us to confront our own mortality and think about what truly matters.
Exactly. And it's easy to get caught up in the technical details and the statistics and the hypothetical scenarios. But ultimately, this conversation is about us, about humanity, and about how we make sense of our place in this vastness of the universe.
It's definitely a humbling experience to contemplate the sheer scale of cosmic events and our relative vulnerability in the face of them.
It is, but I think it also highlights our resilience, our ingenuity, our capacity for hope, even in the face of seemingly insurmountable challenges.
I agree. Throughout history, humans have faced countless threats, both natural and self-inflicted, and time and again we found ways to adapt, innovate, and overcome.
Yeah, it's almost like facing a challenge, even one as daunting as a potential asteroid impact, brings out the best in us.
It can certainly galvanize collective action and inspire a sense of shared purpose. We saw glimpses of this during the COVID-19 pandemic when communities came together to support each other despite the fear and uncertainty.
That's a good point. And in a way, the prospect of an asteroid impact takes that to a whole new level. It's not just about one nation or one community. It's about the entire human race facing a common threat.
It really reframes our priorities and forces us to ask ourselves what really matters. What do we want to preserve? What legacy do we want to leave behind?
And it's not just about grand gestures or monumental achievements. It's also about the small acts of kindness, the connections we make, the moments of joy we experience.
Exactly. It's about cherishing the present moment and recognizing the preciousness of life, both our own and that of all living things on this planet.
It's a reminder that life is a gift and we shouldn't take it for granted.
It is, and while we can't control every aspect of our existence, we can choose how we respond to challenges, how we treat each other, and how we make our mark on the world.
So even though this deep dive started with the potentially terrifying idea of an asteroid hitting Earth, I think it's ultimately a message of hope and resilience.
I agree. It's about acknowledging the risks, understanding the science, and taking action to protect ourselves. But it's also about embracing the beauty and wonder of the universe and appreciating our place within it.
And it's about remembering that we're all part of something much larger than ourselves, a cosmic story that unfolds over billions of years.
It's a story that's still being written. And while we may not know what the future holds, we can choose to face it with courage, curiosity, and a deep appreciation for the incredible journey we're all on.
Beautifully said. And on that note, we'll wrap up this deep dive into the world of asteroids. We hope it's sparked your curiosity, expanded your understanding of our cosmic neighborhood, and inspired you to keep exploring the wonders of the universe. Thanks for joining us.
Sound the alarm. I'm coming up. We'll have the ball. I'm sweet like a buttercup. You're a Barbie doll. Show them all what I'm made of. Strut down the hall. Won't stop till